Today we are going to solve a tree problem on Leetcode. So today we are going to solve a problem on maximum depth of the binary tree. So let's try to understand first what is maximum depth first. So maximum depth means the maximum height of the binary tree could be, let's take this example like 3, 9, 20, 15 and 7. So here maximum height is 2, maximum height is 3, 1, 2 and 3. There are 3 nodes at one this. If you consider 3, 20 and 15, there are 3 nodes, or if you consider 3, 27, there are 3 nodes. So in this case maximum height of the binary tree is 3, because this is the longest possible level we can travels. Okay, so I hope you understand that the concept of calculating the maximum height or maximum depth of the binary tree. Now let's try to solve it programmatically. There are two approaches possible to solve this problem. One is recursive approach and one is uh, iterative approach. So let's first try to understand what recursive approach could be. Like recursively, if we traverse this tree and maintain the depth or the height, then that will solve our problem. So what, at any point of time, let's say at this point of time, what will be the maximum height? The height of left subtree plus height of right subtree plus this height, this current node, right? So left side, subtree height is 1, 1 plus 1 2. Okay, and if we consider right subtree height, then 3 plus 20 plus 7, that 20 plus 7, that is there are 2 nodes, so 2 plus this current node 3. So which is maximum is right subtree. If you consider right subtree and the current node, then it will give us a maximum height. So just we have to calculate at each point of time. Whenever we traversing any node, we just have to calculate the maximum height at that node, and we have to return that maximum height. If we return that, then our problem will get solved recursively. So let's try to solve it on uh, mm, try to write recursively. So if we deal with pointer, then we have to consider the null check. So if null is equal to root, then we are return 0. Okay, then what we have to get, we have to get the left subtree height. Int I left height is equal to, again we are calling same function recursively, max depth root arrow left. Null check is not required because at the first line itself we are checking the null pointer, so null check is not required. So this will count the left subtree height. Then we have to calculate the right subtree height. Int right is equal to max depth root arrow right, and then we have to return max of which two entries, left subtree or right subtree height plus 1, because we have to consider the current node height, current node as well. So plus 1. Okay, plus 1 for current node. Hopefully it will work. No, int I left. Okay, slight spelling mistake. Yeah, so recursively I hope this solution will get accepted. Okay, so recursively this solution is very simple, very short, but if you know how to traverse level wise, then we can also solve this problem using iterative solution. So let's try to solve it that way. So this is one possible way. Let's rename this function to recursive for our reference, and we'll write one iterative function. So for iterative function, what we need, so there are two possible ways. Whenever we traverse tree or graph, there are two possible ways. One is depth first, or the second way is uh, breadth first. So here we are going to traverse level by level. That means breadth first traversal. Okay, so breadth first for BFS, for BFS traversal we need to use Q. If we are using depth first traversal, that is DFS traversal, then we need to use stack. That is a very common thing that we should know whenever solving any tree or graph problem. So just wanted to repeat one more time. For BFS traversal, we need to use Q. For DFS traversal, we need to use stack. Stack can be normal stack, or you can use function pointer as stack as well. So that's fine. So here we are using stack internally because we are using function stack, calling stack, call stack as a stack. So this is kind of you can say DFS traversal. So now let's try to calculate the height using BFS traversal, that is level order traversal. So for that level order traversal we need Q. So let's declare one Q. So Q, we have in STL we have built-in data structure defined for Q. It will be of type tree node, and then let's give name as Q only for our understanding. First null check we have missed, so we have to add this null check here as well. So we have added null check here, then we have declared one Q. Okay, what we have to return? We have to return int I level, which is equal to 0 currently because we haven't considered any level yet. Okay, so and then we have to return this level value once we return this function. So this is basic skeleton. Okay, now to start with, our queue is empty, so, right? So at least we are sure that okay, root node is not null, so we can put that root node into the queue. So we have queue dot push function for that. So we'll put root node into the queue. So this is basic level order traversal or breadth first traversal for tree. So we have to just put the root node into the queue. Now while queue is not empty, what we have to do? We have to pop one element from that and traverse that element. Okay, so for that reason, queue is once queue is empty, we will have traverse all the levels. Okay, so level wise we are going to store the element into the queue. So queue dot empty is queue is not empty. Then what we have to do? We have to take the size, that is int I current level node, number of nodes at current level. So if we take this example, so here at this level only one node is there. For this level there are two nodes, 9 and 20. For this node there are again two nodes, 15 and 70. So level wise we are going to traverse. So first we push that root node into the queue because we have to start with something. So we have to start with root, so that's why we have push the root into the queue. Then we get the size of so this is the first level which we are going to traverse. Then we will traverse this level, then we will traverse this level. Okay, so int I current level node. So at this level how many nodes we have, that who is going to tell us? That is the queue dot size is going to tell us. So we consider that size. Then what we are going to do is now we need one loop to traverse all those nodes. So for int I is equal to 0, I less than this number of nodes, current level number of node count, okay, plus I. So in this way we will be traversing all the nodes at current particular level. Okay, then what we have to do, we have to do is we have to build a queue for next level. Okay, for next level all the nodes should be in a queue, so that at next time when we run this while loop for next iteration, at that time only the node should be present which is next to the current node as a level. Okay, so here what we are going to do is we have to get tree node star current node is equal to q dot top or front. I think front is the function. Okay, so it will give us the current node of this tree. Then we need to pop that node out. Okay, so we need to pop that node out from the queue, delete that node from the queue because we have visited that node. Now if 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 it's left, like current node arrow left is present, then we have to just push that node into the queue. Okay, so for that we have function called push current node arrow left. Okay, similarly for right side, if the right is not null, that means it is present. Current node arrow right is equal to q dot push current node arrow right. So okay, so once this level is travels, we have to increment plus plus I level I level, because we have traversed all the nodes from the current level. So I hope you understood this logic. This is basic logic for traversing the tree or graph level wise. For graph, we have to maintain one additional data structure for visited nodes, but tree, since there is no cycle, so we don't need to do that. We will submit this for all the test cases. Okay, so we have passed all the test cases. So if you observe the time complexity, but this is totally depend on whatever current network bandwidth. So don't bother that about this runtime and memory usage, because this keeps varying. Okay, so I hope you understood the approach for calculating the maximum height of the tree using two ways. One is recursive way and one is iterative way. So I hope you like the video. If you like the video, please share it with your friends, click the bell icon, subscribe to my channel, and thank you. Happy coding.